Alright, divisibility and factors. Well, factors are integers that can be multiplied to equal an integer. So note, 1 is a factor of all integers. 1 will go into everything. And we have some divisibility rules to determine what numbers will go into what other numbers. And the ones that I'm writing down are the easiest ones to remember. Like, I don't have a trick for you to think of 13 or 29 going into a number, but I do have some tricks for the one-digit numbers. So for example, 2. The last digit is all you need to check. Just see if it's even, so 0, 2, 4, 6, or 8. And an example of that would be the number 1074. All we need to look at is that last digit, that 4. And 4 is an even number. So since 4 is even, then it's going to be an even number. And 2 goes. Alright, the next rule for 3 is pretty awesome. You can make your friends seem like you are really smart with this. That's right, all you need to do for 3 is just add the digits. So check this out. The number 852, you could ask somebody, hey, will 3 go into 852? They'd probably want to divide it out. But what you're going to do is you're going to add the digits for 852, and you're going to do plus, and 8 plus 5 is 13, 13 plus 2 is 15, and then just ask yourself, will 3 go into that number? And the answer is yes, 3 goes into 15, so it would be yes. And this is really cool. You could keep adding. So let's say you didn't know about 15. You could add up 1 and 5 and get 6. Will 3 go into 6? And we'd say 3 goes into 6, so it's divisible by 3. Now the rule for 4 is we just look at the last 2 digits and make sure that it's divisible by 4. So really the biggest number you would have to check is the biggest 2-digit number, which could be 99, right? So you never have to check a number bigger than that. And the reason that works is because 4 goes evenly into 100. So check out this number, 5036. You don't need to divide the whole thing out, just look at the last 2, and will 4 go into 36? We'd say 36 divided by 4 equals 9, so it does. So just check the last 2. And in case you're curious, remember what I said about 4 goes evenly into 100? 5036 is just like 50 100s, and we know 4 will go into that. And 36 is what remains. So you're just checking to see if 4 goes into what remains, since we know it goes into all the hundreds. Alright, 5 is probably one of the easiest ones. You just look at the last digit and see if it ends in a 0 or a 5. And to figure out why this works, just think about the multiples of 5. 5, 10, 15, 20, 25, 30. They all end in a 0 or a 5. So a little example there, we'll say 3075 ends in a 5, so it's divisible by 5. Alright, the rule for 6, just check 2 and 3. Make sure that both 2 and 3 go. If they do, it's divisible by 6. So for instance, if we had the number 804, we would just make sure that it's divisible by 2. The last digit is even, so 2 checks. And then add up the digits to see if 3 works. So 8 plus 0 plus 4 is 12. Will 3 go into 12? Yes. So 3 checks. So then since it's divisible by both, it checks for 6. Now the rule for 9 and 3 are linked, so we can kind of tie those together. They're very similar. You just add up the digits and see if 9 will go. And if something's not divisible by 3, it's not going to be divisible by 9. That's just a hint. Well, let's do an example with 9. 8,271. If we just add those digits, 8 plus 2 is 10, plus 7 is 17, plus the 1 is 18. And will 9 go into 18? Obviously we know it does, but if we didn't, we could keep adding them. That's the cool thing about this. If you had a really big number, 1 plus 8 is 9. Will 9 go into 9? Yes. So it checks. I love the rule for 3 and 9. It's just really simple. You can do a really big number and figure out if it goes into it pretty easily. Alright, and the rule for 10, the number just needs to end in 0. Because think of it, 10, 20, 30, 40, they all end in 0. So an example could be 1,240. Our last digit's 0, so it ends in 0. So it's divisible by 10. So count out those $10 bills, and it will always end in 0. Alright, the last rule I want to bring up is a little harder to do. That's why I'm going to put a star by it. And it's a little bit of a challenge. But you just look, it's like 4. You know how we looked at the last 2 digits for 4? For 8, we're going to look at the last 3 digits. So the last 3 digits must be divisible by 8. And sometimes this is useful, and sometimes maybe it's not as useful. But the reason that works again is because, remember, for 4, we said 4 goes into 100 evenly. That's why you just look at the last 2, because that's what's left over. Well, 8 will go into 1,000 evenly, so that's why you just look at the last 3. So for example, the number 4,240, we just look at the last 3 and see if 8 goes. And the reason that works, we know that 8 will go evenly into 1,000, so that means that 8 will go into 4,000 evenly. So then this is what remains. So will 8 go into what remains? Well, 8 will go into 24 3 times, so it will go into 240 30 times. So this is divisible by 8. And our reason is 8 times 30 equals 240. Alright, let's apply what we've learned with our rules for our first example. So we want to list the factors that 27,252 is divisible by. And I'm going to write out my factors, or the ones I'm going to try, which are 2, 3, 4, 5, 6, 9, and 10. Remember, 8 is optional. That's like a challenge. So checking for 2, I'm going to just look at the last number. So is it even? Yes. So that means it's divisible by 2. Alright, checking for 3 to see if 3 will go into this number. I'm going to add up the digits. So 2 plus 7 is 9, plus 2 is 11, plus 5 is 16, plus 2 is 18. So there, the sum is 18. And now I need to see, will 3 go into 18 evenly? The answer is yes. So 3 is divisible. And look at 4. 4, we just look at the last 2 digits. So the 52. Well, 4 into 52. If I don't know this, I'm going to write it out. So 4 times 1 is 4. 4 times 3 gives me 12. So yeah, we'll go evenly. So 4 goes into it. Alright, the rule for 5. 5, I just look at the last number. Does it end in a 0 or 5? Nope. So it's not going to be 5. Let's check 6. Is it divisible by both 2 and 3? Sure is. They're both circled. So it's divisible by 6. 9 is the same rule as 3, except we want to see if 9 will go into it. So we added the digits up and got 18. And then will 9 go evenly into 18? Yes. So we're going to circle the 9. And our last one is 10. Just look at the last digit for 10. Does it end in a 0? Nope. So it's not going to be divisible by 10. All right, let's move on to factoring, listing all the factors. We're going to use the rainbow method of factoring. And that's when we connect the pairs of factors, and we always start with 1. And the biggest number that we try is the square root of the number. So, for example, if it said list all the factors of 44, list all factors of 44, we first need to start with 1. So 1 times what is 44? 44. And I'm going to keep going, but just as a shortcut, the square root of 44 is about, well, I know the square root of, or I can say what number squared is close to 44? Well, 6 squared is 36, 7 squared is 49. So I need to try numbers that are less than 7. That's the biggest number I should try, is numbers that are less than 7. I don't need to try 8 or 9 or 10 or 11 because I've already tried all the different possibilities. And that really just marks the halfway point. I'll show you what I mean. So we have 1 and 44. Now I'm going to try the next number, 2. It's even, so 2 will go. I just cut 44 in half, and that would be 22. Next I'm going to try 3. But look, the sum of the digits is 4 plus 4 is 8. 3 will not go into 8, so 3 doesn't go. The next one I try is 4. 4 will go into 44 11 times. I can try 5. It doesn't end in a 0 or 5, so 5 doesn't work. I can try 6, but it's not divisible by both 2 and 3, so 6 doesn't work. 7 I don't have a rule for, but 7 times 6 is 42, 7 times 7 is 49, 7 doesn't work. And now I'm done, because I've already tried through my halfway point. So that's the maximum number I need to try. And you can connect them with your lovely rainbows if you would like. So 1 to 44. Obviously this part is not necessary, but you can just see that they are connected. This is why it's called the rainbow method. It makes a rainbow. And that helps you to not forget the pair that goes with it too. All right, let's do an application to what we've been doing. All right, let's say there are 30 students singing in a school concert, and each row of singers must have an equal number of students. If there are at least 4 students in each row, what are all the possible arrangements? And there was the choir singing. Great job. What a fantastic job they did, huh? All right, so we need to list our factors of 30. And the rows have to be at least 4. So I'm going to write 30 down, and I'm going to do 1 and 30. So I could have 30 rows of 1. I could do 2 of 15, so 15 rows of 2. 3 of 10. And will 4 go? No. Will 5 go? Yes, 5 and 6. and I'm done. So now I just need to list them. And don't forget your rainbow. Not too bad. And there are all my possibilities. 1 row of 30, 2 rows of 15, 3 rows of 10, and 5 rows of 6.